A supernova, pluralized as supernovae, is an explosion of a star that happens at the end of the star's life cycle. The explosion is extremely bright and can be brighter than its galaxy for a period of time. A supernova happens due to a change that takes place in the core of the star. A star has a burning core where elements react and fusion takes place. The core first burns hydrogen, which is converted into photons. These photons push against the force of gravity to try to pull the star in on itself. For most of the star's life, the forces of gravity and the photons are balanced. As the hydrogen is used up, the star moves to helium. Smaller stars do not progress past the helium stage because they do not have the mass necessary to support the fusion of other elements. Stars with a large enough mass move to carbon, then neon, and continue through the elements until they get to iron. Iron is significant to understanding how a supernova occurs because most stars, even the largest ones, do not have enough energy to fuse iron. It takes more energy to create this fusion than the star produces. As a star burns through all of its fuel, it begins to cool. The two opposing forces of photons pushing out and gravity pulling in become unbalanced. Gravity is able to take over, and the star collapses. The explosion that results from the collapse is a supernova. Supernovae occur quite frequently. According to the Department of Energy, it is believed that a supernova happens somewhere in the universe every 10 seconds. Supernova names are based on the spectra, spectrum, or light signature released when they explode. There are two main classifications of supernovae, Type 1 and Type 2. A Type 1 supernova tends to involve two stars, a white dwarf and a companion star, while a Type 2 supernova involves a single star. A Type 2 supernova has hydrogen in its spectrum, while a Type 1 supernova does not. The more common supernova is a Type 2 supernova, also called a core collapse supernova. These are massive explosions that happen from enormous stars that can be larger than 8 times the mass of the Sun. Due to the mass of this type of star, it can fuse elements up to iron. As it runs out of fuel, the star implodes and then explodes, sending elements shooting out into space. There is a large amount of hydrogen and helium that is seen in the spectrum of a Type 2 supernova. The explosion leaves behind a nebula, which is a cloud of hot gas, and one of three things. A large star will explode, leaving a very dense neutron star. If a star has a mass more than 25 times that of the Sun, the star collapses in on itself with such force that it creates a black hole at its core. A star with a mass 100 times that of the Sun will explode and completely disappear, leaving no trace of itself behind. Type 1 supernovae are not as common, and there are three main subcategories of Type 1 supernova. Type 1 supernovae can involve a white dwarf star in a binary orbit with another star. A white dwarf is the carbon-oxygen core remnant of a star comparable to the size of the Sun. A Type 1 supernova can also involve only a single star. During the life of the star, its outer layers are lost, and much of the hydrogen in the star is stripped in the process. Therefore, these are often referred to as stripped core collapse supernovae. The spectra of types in this category do not include hydrogen.